EOC review questions. All right, so we have a rational. This is a multiplication. So as soon as you see rationals, we're going to always think about factoring, especially trinomials. So we're going to take our trinomial. We're going to take a times c. So in this case, a is 1, b is a negative 6, c is a negative 16. So a times c goes on the top. That's negative 16. B, negative 6 goes in the bottom. We're going to put AX, which, as I've explained to you before, I like to use this way because it works when A is 1 or when A is not 1, either way. And it's just a consistency. So we're looking for the numbers that multiply to give us 16, but we'll add or subtract to give us negative 6. 4 times 4, 4 is doubled, so we're good. 1 and 16 will give me 14 and 17. 4 and 4 are going to give me 8 or 0. So we're going to go with our 2 and 8. That 6 is negative, so our biggest number is going to be negative. If I owe you 8 and I want to owe you 6, I'm going to pay you 2, so that's going to stay positive. So that means we can get rid of this guy, and that becomes x minus 8 and x plus 2. I'm just going to work across the top. So x squared plus 7x plus 12. A is 1, B is 7, C is 12. AC goes on top, B goes on bottom, A times X goes in the upper corners. We're looking for what I multiply to get 12 that could add or subtract to give me 7. So 1, 2, 3, 4 has already happened, so we've got our sets. That's 13 or 11, 8 or 4, 7 or 1. So we're going to go with 4 and 3. 7 is positive, so 4 is definitely going to be positive. If I need $4 to turn into 7, I'm going to add 3, so they're going to both stay positive. And that's going to be x plus 4, x plus 3. Now looking at the bottom, a is not 1 here, so I'm going to factor out a negative 2, or at least try. X squared. Negative 14x. If I pull out a negative 2, I'm going to get a positive 7x. Negative 12. If I pull out a negative 2, I'm going to get a positive 12. That one's done. Now, hopefully you see it. The x squared plus 7x plus 12 is right here. We've already factored it. So we're just going to rewrite it. We're going to hold on to that negative 2. That's going to be x plus 4, x plus 3. Moving right along. 2 in the front again. You want to check for a GCF whenever it's not a in the front. I'm going to try 2. That does work all the way through. So again, we're going to get rid of him. X squared minus 6x minus 16 is exactly where we were here. So we don't necessarily have to factor it again. You have your work over in the corner. And that's going to be x minus 8, x plus 2. Now that you have simplified, or we have factored it all the way through, you would theoretically, if it should ask you for it, this is when you would start working on your restrictions. And that's taking all of your factors in the denominator, set it equal to 0, and then solve for each one. Negative 2 is never going to equal 0. And I know that's not what this question is asking, just a good review. So we're going to have a negative 4 as a restricted value. X plus 3 equals 0. We're going to have x equals a negative 3 as a restricted value. X minus 8 equals 0. We're going to have x is 8. And then x plus 2 equals 0. And that's going to be x equals a negative 2. So our restricted values, extraneous solutions, I think that's all I can think of at the moment. Negative 4, negative 3, negative 2, and 8. So all 4 of those numbers, if we got those and we were to solve this puppy, are not allowed. Once you factored, dropped an F-bomb, you found your restrictions, then we're going to start crossing things out that match from top to bottom. So x minus 8, x minus 8, x plus 2, x plus 2, x plus 4, x plus 4, x plus 3, x plus 3. Once you identified it here, you could probably go ahead and cross these guys out altogether, unless, again, the question is just discussing restricted values, and then you have to be able to factor it to be able to identify those. There's nothing left in the top. There's a negative 2 and a positive 2 still left at the bottom. We do want to make sure you leave it in the denominator, so you're going to need that space holder at the top, and our answer is going to be B. All right, inequalities. We have a quadratic and an absolute value. And we're picking our best answer choice. So I would start, because their first one is quadratics, I'm going to look at my quadratic. I see that's a solid line. So that means this guy's out because there's not an equal to, and this guy's out because it's not an equal to. So we know we need an equal to in our quadratic. to this quadratic, it's shaded up or on the inside, and that is including all the larger y values. So our inequality shading is based off the y value, so your vertical axis. The big numbers are up, so that's going to be y is greater than or equal to, this is the wrong one, so our answer is C, and ultimately you can walk away at this point. Now, our absolute value, they're counting by twos, which doesn't help very well. You do want to make sure you don't use an equal to in this one. So this one has gone here and this one's gone here. If that's all you know, the -3 in this puppy messes you up a little bit as far as maybe if you're tracking your transformations that we've done before. But also just to remember in Desmos, you can do these in Desmos because you have access all the time. So if I want to try to replicate this or check my answer, I know it's y. I'm hoping it's y is greater than or equal to. So we're going to use our keyboard. Greater than or equal to 1/2 x squared plus 3. Make sure you put it in right. If you don't put it in right, there's nothing they can do. That looks good. It is shaded up and above. And then we would try our other one because we're just basically, what they've showed in the picture is the overlap. So this is going to be y is less than. Again, you can get that inequality in the keyboard down at the bottom. I'm using the keyboard on my computer. So 3x plus 5, close your absolute value bars. This is counting the way they automatically like format this. I would probably, for the way my brain works, I would get rid of my minor grid lines and I would count by twos because that's what we're comparing it to. And then I would come back and I would try to put it in the kind of look, to make it look the way theirs looked. And that vertical goes all the way up to 30. So we're looking real far back out, like we're backing out. And that's why it looks so tiny. Now I can see that 10 and all the ones they saw. If you come in a little bit, you can see it's a little less than 2. And the overlap is what it showed in the graph on your paper. So you can check if you have some question. Like I said, I feel like this one could give some of you some trouble because it's not necessarily left to the 5 and the change of increase is as you would necessarily think it would be if you're just going off rules. All right, number 3, the length of a rectangular prism. Now, this is a fun one. It's a little fuzzy, a little wild. It's a great EOC question. Let's see if I can get another sheet of paper so I can show you all the work. The length of a rectangular prism is 3 feet longer than its height. So we know that length is equal to 3 feet longer than its height. So height plus 3. The sum of its length, now remember sum means we're going to add length, height, and width is 13. What is the volume in cubic feet of the rectangular prism based on its height, x? So I use length and width, and I use their letters, and height for that matter. We can call the height x because all of it is based off height. So we could do length equals x plus 3, height equals x, and width, we're going to call it w because we don't know. We're going to rework this guy. So our length is x plus 3. We're going to add that to our height, which we're going to use an x, and we're going to add that to the width equals 13. We need to know what the width is because, again, in which way you decide to draw this prism. Remember, if it's a rectangular prism, to solve for volume is just length times width times height. And in this case, our length is x plus 3. Our width is unknown, and our height is x. So we're going to multiply these together to get the volume, but we need our width first. So we're solving for w here. There's an x and an x. So we have 2x plus 3 plus w equals 13. Again, you're working to get that w by itself. So I'm going to subtract 3. And that's going to give me 2x plus w equals 10. And then I'm going to subtract 2x. I'm sorry, I left off the plus from both sides. And that's going to give me my w is equal to 2x plus a negative 2x plus 10. So now I have my width. So now my width is equal to 2x plus 10 with a negative 2. We're now going to multiply these 3 together because that's how we get volume. So height times length times width. You can box method, you can FOIL. I'm going to just distribute this x through here. So x squared plus 3x negative 2x plus 10. I think if I remember, most of you like box better. Negative 2x times x squared is going to give me a negative 2x to the third power. Negative 2 times 3 gives me a negative 6. X times x is x squared. X squared times 10, 10x squared. 3x times 10, 30x. And now clean up to get your answer. So any like terms, we do have like terms on the diagonal. So we're going to pull out our 2x to the third power. If I have 10 and I lose 6, I'm going to have 4x squared. Then last but not least, 30x. And that's going to be the volume of that prism. It's a matter of just slowing down and reading very carefully. Lots of math though, but you have this math. You've done all math 1, 2, and all the way through. You should, if you can slow down, should be able to manage this guy. If you have questions, obviously always reach out to me and let me know. Number 4, the population of a small town was 2.5 thousand. The population grows at a rate of 2.15. Make sure you notice that says 50%. After how many years will the population have doubled? So if we're starting at 2.53, doubled is going to be 5.06. So that's where we're trying to shoot. This is a growth or decay. It's growing. So we're going to put our 2.53 as our starting amount. 1 plus, we're going to change this to a decimal, which means divide by 100 or move the decimal place 2 to the left. And we want it to equal 5.06. Now, this could be rewritten. You may see it in another place if they give you more information. You can see it either way. This is more than $1, so that's how you know this is growth. If they were to write it this way you see the plus, so hopefully you know that means it's growth as well. To solve for x, this is where we learned our logarithmic stuff. We need base, an exponent, and an output. So we're going to divide by 2.53, which makes this a really nice, neat number. That's going to end up giving us a 2. So it's going to be 1.0215 raised to the x equals 2. Now we're going to convert it to logarithmic form. Push the base down to the basement, go get our equals 2, and then grab our exponent. So log base 1.0215 of 2 equals x. You can plug that directly into Desmos and get an answer. Just to call out for future math classes, if you do change of base, that's log 2, excuse me, over log 1.0215, and you can type it in that way and should get the exact same answer. For Desmos, let's do it there because I think most of you are going to be more apt to do it that way. So we're going to type in log. We're going to go down 1.0215. Again, just pay really close attention and make sure that you are in the like down. It's a subscript and you got all your numbers right. You switch your percentage to a decimal in the beginning, and then we're going to have a 2. Again, make sure it jumps up and is back on the main line with log. It's 32.58. We can call it 32.6. Read your instructions as far as where to round. I got some questions in some of the ed puzzles in the last couple of weeks. Will it always round to a certain place? Absolutely not. It would depend on the teacher, the worksheet, or the program, the test question, who wrote it, what they want, and usually how the number pans out. All right, guys, 4 EOC questions in the bag. Great job.